learn about the interpolation for unequal h. So how to find out the interpolating polynomial if h is different. So divided difference formula is useful for unequal h. So h means what? I have already told you in previous classes that h is the difference in x variable. H is difference in x variable. So for unequal h, Newton's divided formula and Lagrange interpolation formula will be applicable. So if you find that in x column, if I write x0, x1, x2, x3 and the corresponding y column also you will write y0, y1, y2, y3. So this is x1 minus x0 in previous Newton's forward interpolation formula, Newton's backward interpolation formula. We have seen that the h is equal. So that's why for equal h we are applying Newton's forward and backward formula. But for unequal h you will be applying Newton's divided difference formula. Newton's is a very important formula, Newton's divided difference formula. So for unequal h you can find while applying this Newton divided difference formula x1 minus x0. Here you can see x1 minus x0 not equal with x2 minus x1 not equal with x3 minus x2 not equal with x4 minus x3, like this. So h is distinct for each interval. So that's why we are applying here Newton's divided difference formula. Now if what is this, like operator symbol, here the divided operator will be Aitken symbol. What is the symbol is known as Aitken symbol. This symbol is applicable. So you can write fx1 x2. You can write this fx1 comma x2. You can write fx2 minus fx1. Divided operator will be applicable like this, x2 minus x1. This is your fx1. This is the operator, first operator. So this is all about the finding value of Newton's divided difference formula. First we'll discuss about one problem, that is, suppose one problem is there, like x column you will find 1, 2, 3, 4. In y column suppose it is given 8, 27, 64. So these are the data that is given and we have to apply Newton's divided difference formula. So first you can first order divided difference operator you will be applying. You can write Aitken y, you can write like this, and then Aitken square y, second order divided operator, then Aitken q y, third order divided operator. This is known as first order divided operator. Second order divided operator. Third order divided operator. This is all about the various kind of operator that will be applicable in Newton's divided difference operator formula. So first order you will be find like 8 minus 1 by 2 minus 1 first. then 27 minus 8 divided by 3 minus 2, then 64 minus 27 divided by 4 minus 3. So this is about your divided operator formula. Now you can calculate 7 by 1, that is coming 7, then 27 minus 8, that is coming 19, 19 by 1, that will be 19 here, then this is coming 7, 37 by 1, so you will be getting 37. So you can find this is your first order divided operator, and that is symbol as Aitken Y. So that will signify the first order divided operator, and then we'll go to move to nebula square, like Aitken square, second order divided operator. So how you will calculate? You see 19 minus, this is your nebula 1, Aitken 1, Aitken 2, Aitken 3 in first order. So 19 minus 7 divided by 3 minus 1, can calculate, and then 37 minus 19, 37 minus 19 divided by 4 minus 2. You see how it is calculated in second order divided operator, that is 12 by 2, that is coming 12 by 2, that is coming 6, and then 18 divided by 2, that is coming 9. So this is about your second order divided operator. Then third order divided operator. Third order divided operator will be calculated like this: 9 minus 6 divided by 4 minus 1. So last value minus first value. So we will be getting 3 by 3, that is equal to 1. So you can calculate in this way the Newton's divided difference table. This is about your the full constructions of the table. This is about your total data, how it is calculated in first divided operator, and then second divided operator column, then third divided operator column. In this way you can calculate the divided difference table. Now suppose it is asking yx, or correct, fx. So this is the value, that this is the formula of fx, that fxn plus, this is the formula, so that we can calculate first you will draw fxn plus fx0 plus fx0 plus x minus x0 into the first Aitken operator, then x minus x0 into x minus x1, second order Aitken operator, plus x minus x0 into x minus x1 into x minus x2, x minus x2, that will be qy0. This is all about the formula. So fx0 means the initial formula, initial y value, that is your 1, plus x, there is no value that is asked in the question about x, so you can put it x. If somewhere it is asked x is the value, then you can put the value x minus x0. This is your x0, x minus 1, Aitken y0 will be 7, plus x minus 1, x minus 1 into x minus 2, that will be into 6. Del square column you have to take 6, you have to take 7, then you have to take 1, and this value is your 1. Y value, the initial value is your 1. So x minus 1 into x minus 2 into second order divided operator, the first value you are getting 6, then you can write x minus 1 to x minus 2 into x minus 3, and the third operator, the last one, the last column, you can see the third operator value is 1. So you can put the values like this and you can calculate like this, that the Newton's divided formula, that is fx0 plus x minus x0 into first y0, first order divided y0, then x minus x0 into x minus 1, second order y0, plus x minus x0 into x minus x1 into x minus x2, that is third order y0, plus likewise, but not how much operated column you are getting, that depends upon the to extend the formula. If divided operator, fourth divided operator is there, then you can calculate up to that value. Like if you are getting the fourth divided operator is there, then you can see you have to take x minus 1 into x minus 2 into x minus 3 into x minus 4, because here we are ending here with the value x minus 3, because there is no such value in the fourth divided operator. So that's why you have to end here while you are getting the third order divided operator, only one single value. There is no such value that is to be coming under fourth order. So in spite of, you are now deleting the value of x minus 4. We are not taking the value of x minus 4. Here you can see. So 1, that is your first value of y, you have taken 1, plus x minus x0, x0 is your 1. So you are taking it, this is your y0, this is your x0. So you are taking, this is your x1, this is your x2, this is your x3, this is your y1, y2, y3. But you can see why you are not taking on such different values, because from this all these values, this del, like first Aitken value, second order Aitken value, third order Aitken values are calculated. So first fx0 value is 1 plus x minus x0, that is when 1, x minus 1 into the first Aitken order, the first value is 7. So here we have mentioned 7 plus x minus 1 into x minus 2 into this second order difference table, that is 6. So you are taking the first value 6 here, then x minus 1 into x minus 2 into x minus 3, then third operator, third column value, that is your 1. So this is all about the calculation of Newton's divided formula. So now you can calculate it by multiplying all this value and you can get the answer. Definitely you will get a polynomial. So in that polynomial, if any x that is asked in the question, they can put the value in place of x and you can get a number. So now you can calculate this formula like y equals to 1 plus 7x minus 7 plus x square minus 3x plus 2 into 6, and then plus x square minus 3x plus 2 into x minus 3, that is your total polynomial. 1 plus 7x minus 7 plus 6x square minus 18x plus 12 plus x cube minus 3x square minus 3x square plus 9x plus 2x minus 6. So that is 6x square, so that will be cancelled, and x cube will be there because there is no such value to add or subtract for x cube, and 7x minus 11x, and this will be cancelled because 11, so the 18x is cancelled, and then 1 plus 12, that is 13 minus 7 is 6 minus 0. So answer you are getting, I think, x cube plus 1, that is very small value you are getting the answer. So x cube plus 1, that is your answer. So here fx equals to x cube plus 1. So if I ask about such value that is not given in the table 1, 2, 3, 4, like you can get a 4.5, so you'll get 4.5 whole cube plus 1. If somebody asks you find the value of x equal to 4.5, then you can put the value of x in place of fx, and you can find the value of fx by using Newton's divided formula. Then you can go for Lagrange interpolation formula, that is also applicable for unequal h. So what is the formula, so that how you can apply Newton's divided formula and Lagrange interpolation formula for unequal h. So you can ask where to apply Newton's divided and where to apply Lagrange interpolation. So this is quite easy to understand. So if any question asks you have to apply this formula, then you apply, otherwise you do, whatever is compatible with you, we can apply. Lagrange interpolation formula. This is your Lagrange interpolation formula. So this is also the same thing, like some x is given, like the same problem you can also apply, that is your x and y. Suppose I am taking 1 and this is 1, 2, 16, 3, 81, 256. This is the table that is given for x and fx, and you can apply that. This formula is applicable for whatever we can apply, the h should be unequal. Like somewhere you can apply also for equal h, but generally it is applicable for unequal h. So you can apply Lagrange interpolation formula for unequal h using the various kinds of numericals, like somewhere y equal to x cube, and the difference in x and y, they are quite different. Somehow it is not required that in Lagrange table you need not draw a table, you have to apply only the numericals. Suppose the question is given that x equal to like x0, the initial value, and the next value is x1, and the next value is x2, and next value is x3 and x4. Then in what way you will be calculating? Suppose the first value is given, I am just changing these values, like 1, that should be unequal h should be there. You can find 0, 1, 4, 6, 0, 1, 4, 6, and the corresponding y value is given 1, minus 1 and 1, minus 1. So you can see the h is quite different, and h means the difference in x value is quite different. You have to apply Lagrange interpolation formula. So you can understand the initial value that is given as x0, the next value is x1, this is your x2, this is your x3. This is all about your, and this is your y0 value, this is your y1 value, this is your y2 value, this is your y3 value. And the same problem you can also apply Newton's divided formula and Lagrange interpolation formula. So if you are considering to find fx, how to apply? You can generally, you don't need to draw a table here. This is the specificness of Lagrange interpolation formula, that you need not draw the table. Only we can understand that for the first value you are calculating the polynomial. So you can draw like this: x minus 1, x minus 4 to x minus 6, you see, divided by, now the x0 is your 0, so you have to put like this: 0 minus 1, 0 minus 4, 0 minus 6 into y0. This is your y0, that will be 1. this is your first part of Lagrange polynomial. Then x minus 0, you are considering the term for x1, so that will be x minus 0 into x minus 4 into x minus 6 divided by, what is x1? 1. 1 minus 0, you can put instead of x, that is your x1. 1 minus 0, 1 minus 4, 1 minus 6, that is minus 1. What is y1? So y1 is multiplied like this. Next, this is your y2, this is your y3. Now you can calculate x minus third part, x minus 0, x minus 1 to x minus 6 divided by the second term is x2 is your 4. So 4 minus denominator 4 minus 0, 4 minus 1, 4 minus 6 into y2. y2 is your 1 again. Then the final part will be 4 terms, because the 4 into 4, x for every data, 4 items in x and 4 items in y. So you can calculate the 4 items in fx also. So x minus 0, x minus 1, x minus 4 divided by 6 minus 0, 6 minus 1, 6 minus 4 into minus 1. So this is all about Lagrange interpolation formula. This is all about Lagrange interpolation formula. So you can calculate all these values and get the answer. If it is asked that somewhere you have to find 1.5, 0 to 6, any value you can put and you can apply in place of x, and then you can take the value of fx. So you can just calculate here what is the fx value, and then you can see what is the difference of Lagrange interpolation formula and Newton's divided formula, so that which will be easy for you to calculate if you are getting some x with specific fx is there, and then you can calculate some fx formula using this Lagrange interpolation as well as Newton's divided formula. But this is all about you can just simplify it like fx will be, you can calculate further, x minus 1 into x minus 4 into x minus 6 divided by minus 1 into minus 4 into minus 6, so that will be minus 24, the denominator. Then you can calculate x minus 0, that means x into x minus 4, that is your x minus 6 divided by 1 into 1 minus 4 into 1 minus 6. So instead of 1 minus 4 you can calculate minus 3 and then minus 5 to 1, so that will be 15. So in that way you can solve it, x into x minus 1 into x minus 6 and divided by 4 into 3 into minus 2, then you can calculate the denominator, and instead of x, if some value like 0.5 or 1.5, 2.5, 3.5 or 4.5 to 6, you can put the value in place of x, and totally numerically you can find a fx value. The same problem also you can apply through Newton's divided formula, so that if you draw a column and Newton's divided formula, from Newton's divided formula, what is the value of fx you are getting? X and then fx, then the first order Aitken fx, the second order fx, and the third order fx. Can calculate, and this is 0, 1, 4, 6, and then 1 minus 1, 1 minus 1, and the first order will be minus 1 divided by 1 minus 0, and then 1 minus 1 divided by 4 minus 1, minus 1 by 6 minus 4, can calculate, that is minus 2, 2 by 3, minus 2 by 2, that is minus 1, that is 0.667, and this way 0.667 plus 2 divided by 4 minus 0, and minus 1 minus 0.667 divided by 6 minus 1. So in that way you can calculate 2 2.667 divided by 4 and minus 1.667 divided by 5. In that way you can getting 0.667 you are getting, and here also 0.333 you are getting. So here you can calculate 0.333 minus 0.667 divided by 6 minus 0, that is 0.333 I think divided by 6, so that will be 0.055 like this. So in that way this is your the values you are getting by applying Newton's divided table and apply the formula.